Vikas is not here. Okay, doesn't matter. Vikas is also here. He's just shy. Okay, as I promised you, we will have a short introduction into Solidity smart contracts. So let's start from the purpose of this workshop is to explicitly explain you and make everyone aware the difference between different ERC standards like ERC20 and ERC721. Maybe let's start from explaining what the hell is ERC. So ERC is Ethereum request for comment. Those are different standards that developers make to make the coding in Solidity and using Ethereum easier. And one of very first such standards is ERC20. ERC20 allows you to build basically cryptographic tokens, which are fungible tokens. You can think about it about euro or rupee. All tokens are the same, they are interchangeable. You can choose if you want your tokens to be dividable into smaller chunks. So you can send, for example, someone one token. And so this is ERC20. These are fungible tokens. So all tokens are the same, like euros or Indian rupees or Ukrainian hryvnia. Another type of another standard that was created and suggested sometime later was ERC721. ERC721 are called as well NFTs. Those are NFT is non-fungible token, which means that all tokens are different. What does it mean? You can think about it as about art, where all pieces of paintings are different. In case of ERC721 tokens, you can have different information stored in each of the tokens that are minted from mother contract. These tokens can be used in real life, for example, as a software licenses. So imagine you create, as owner of some software, you create a licenses as ERC721 tokens. When someone is purchasing a license at your website, you basically ask them for their public address, and you send them this license. So as you send to this person, maybe I'm not sharing anything interesting, so maybe let me show you my face. As soon as you purchase this license, this license is part of your wallet. So me as a owner of software company, I send to your wallet this ERC721 token, where each token is unique and each token has different ID of license, website or something like that. And later, when you try to use my software, you just register and you provide cryptographic signature to prove that you are the owner of a wallet which holds this NFT. And then I verify your signature. I verify the authenticity of this token, and I grant you access to my application. I can choose as the owner if I want these tokens to be transferable. So if you are allowed to resell the license later to someone else, so as soon as you and the license is just a NFT. So if you transfer NFT to someone else and you try to log into my software, you can no longer prove that you own this token, because you don't. This is quite important thing. So you send the license to some other person, and this other person can then prove signature to check it. Hey. Let's maybe focus on two real use cases. One of our projects we wrote for biggest Dutch energy provider was Holoni. Holoni is a software which allow user to get some incentive in a way of cryptographic tokens to make them more eager to put more photovoltaic panels on their roofs. So you probably currently know that in Europe we've got big problems with energy right now, and in order to get some pressure from big power plants, Dutch government decided why not allow people to put PV panels and then resell this energy to the grid. So during the day, power plant won't create won't have so much stress on itself. So this is Holoni, and you can see their attestations. So each time a user produces some energy, we can create attestation for that energy to prove, for example, that at 1 p.m. This user produced 323 watt hours, and this is actual production of energy. And at a few hours later, 1,400. And this is an NFT. So us as an auditor, we have access to smart meters of the users, and for each hour we create NFT which is representing created energy. This is a later smart contract. You can view this smart contract, so you can decode the input that this was production, who was the attester, so that the attester is the person that is proving that this energy was actually produced. In this case, this is Energinet, which is this energy provider. They put those smart sensors there, and hash of the details of the whole production of this energy. So this is NFT. You can view it. You can as well transfer it. This is part of smart contract. And this NFT was created in the smart contract of attestation contract. So all those NFTs are different energy created by different users. When user wants to get a reward for energy, the user can pick a few types of these attestations, can pick the type of voucher, and can get a reward voucher. So apart from selling the energy to the grid, user wants to as well get some reward, and then different companies can cooperate, or city municipality like Copenhagen City or like IKEA in this case, and IKEA will give you a reward vouchers. So this is another NFT. This is an NFT which consists of multiple attestations. So I want to claim my reward for those attestations from those different hours I created, and you can see here that attestations ID are for those attestations. Of course, you cannot reuse one attestation multiple times. You can see that this is Copenhagen solar voucher. This is type of production, and value of those free energy attestation is 2,859 watt hours. And what will happen if we claim that? Let's swap to Rinky testnet. What will happen if we claim that? There is a reward pool, and reward pool for this reward voucher of number 25 will send me some tokens. So this user, let me show you the account of this user. This is probably Holoni user, but I'm not sure. Let's check I think I can, yeah. So I can claim these tokens for this user, and I can open MetaMask. MetaMask allows me to get signatures, so to sign the different contracts, and I can see I've got 50,000 Holoni tokens. When I claim this reward voucher 25 to that wallet, this transaction will ask IKEA reward pool, hey reward pool, this guy wants to exchange those tokens and claim the attestation and claim the reward. And you could see that right now, instead of 50,000, I've got 53,000 because energy generated by those free attestations was almost 3,000 watt hours. So you can see here I got some tokens. And this is how you can use NFTs, not by purchasing some stupid ape images, but by actually proving something which is not replaceable, like creation of energy, like a software license. Okay, let's maybe create first ERC20 token. ERC20 token, which is this replaceable token. Let me call it Jacek token. So please open Web3 Wizard. I put a link in the chat here to Open Zeppelin Wizard. Open Zeppelin is a library that is keeping those standards in one place. So let's call this token Jacek token. JTK. And we can choose different things. I want to be allowed to mint this token, which means the owner, so the person who created this Jacek token, can as well specify amount of tokens to be sent to specific address. So I can create out of a thin air tokens. Burnable means that I can get rid of the tokens, which means that those tokens won't exist later in the future. So I can get rid of the tokens. So in case I want to remove some tokens or destroy NFT, these are not NFTs, these are fungible tokens. But if I want to as well destroy some tokens, I add this burnable. And you can see the code for burnable, what is it doing. So those are all different libraries created. And you can see that the token is inheriting ERC20 standard and is type of ERC20 burnable and ownable. Ownable means there is one owner, so the one guy who created. As well, other access control is roles, so you can have a minter role or owner roles. You can as well have role-based access, but for this example, let's make it ownable. And let me check what I put there in the token. Burnable, ownable, and that should be it. And I want, to create this token. So I copy that code. I can open it in Remix. Remix is IDE to work with smart contracts. Or I can, I've got already my workspace created, so I can copy paste it here. So please create all of you your own token, call it your name token and some symbol, add their mintable and burnable. There's as well pausable, so you can pause transaction and transfers of the tokens. Premint, which means I create X tokens at the beginning. So for example, I create 100 tokens as I create this contract, and snapshots and so on. It really doesn't matter. And it's important to add here a security contract. Security contact because this is creating this comment here, and it will be later useful when we validate that token. Okay, so let's create a file for that token. Let's call it Jacek token.sol, and let's create a token. Did you do it, guys? just interact a bit with me. Okay, so we need to add one more thing. So as you see, as you see, these Holoni tokens don't have any kind of decimal point. You can choose decimal point, so number of zeros after the comma. To make it easy, let's agree that there won't be any decimal point. So it will be easy for you to understand and make transfers. If you, for example, don't create this decimal point, this will be 10 to the power of decimals, because this is a number of, so if I want to create one token, I need to, when I create a token, so it's called minting, or when I send a token, I need to send 1 times 10 to the power of double asterisk is to the power of decimals, and decimals is hard-coded as 18 zeros. So if I want to overload that parameter, I need to specify that I don't want to have any decimal points. I want to have 0 decimals, which means 10 to the power of 0 is 1, so 1 times 1 is 1. So whenever I specify here amount of tokens as 2, I will create or send to someone 2 tokens, and when I send, and then I won't be allowed to send, for example, 0.5 tokens. So as soon as we did that, let me copy that to the chat so we can include that faster in your contracts. Let's go to let's maybe talk a bit about Remix. So Remix allows you to create contracts. So like we here, we have a constructor, we have a function which is minting, we have this decimal point, but as well there is a compiler. So Remix allows me to compile this token. When I click here, Remix is compiling the token. And as well, Remix is allowing me to deploy that token. So I can choose different environments to deploy. Remix, if you pick here Remix Virtual Machine London, this is creating predefined accounts. But since we want to show that it's actually working, so we can transfer between each other different tokens, we will use, I think it was not Ganache, injected provider metamask. And as soon as we do that, we can connect our wallet. So let me connect, for example, this wallet to this deployer, so you can deploy as well to the actual chains of testnets of Ethereum. Okay, did you open your MetaMask? You need to create their account and see something. Do you see some wallet here? Injected provider. What's happening when you try to do it? Do you have MetaMask activated? You need to have MetaMask, and in MetaMask there are different networks, so please choose Rinkibi. Rinkibi is a testnet of Ethereum, and here you can create multiple accounts. And to be able to make some transfers, there is a faucet. Faucet automatically sends you a X number of this fake Ethereum tokens. So please open MetaMask, pick your wallet, in this case 0x7CD will be my wallet to deploy stuff, and click here and send me ETH. And you can see here it's supposed to send you some Ethereums, and you can observe this transaction in Etherscan. So in a few moments I should be able to see in activity. Oh, I got it already, 0.1 Rinky. Do you have it, this injected provider metamask? It's important. Okay, so go to the faucet, and in the faucet copy this address of your wallet and paste it here. Remember, wallet, you don't need to register wallet. Wallet is just a asymmetric keeper. It's just wallet is just a public and private key. Is nothing you can register. Nothing you should register. So add your wallet and request some tokens. Did it work, guys? Okay. There is as well a very useful function here. If you open settings, so click this bubble, open settings. In settings, there is experimental, and in experimental, use token detection. This will automatically detect the tokens, ERC20 tokens you got to your minted to your account. Okay. So you click here, settings, experimental, and use token detection. So did it work, guys? Talk to me. You should have 0.1. Okay, and now when you compile it, click here, compile Jacek token, and compile your tokens, of course. Go to deployment, pick injected provider, and in injected provider, pick the contract, Jacek token, and click deploy. When you deploy, metamask will ask you to provide signature that you are deploying it from your address, and will request you to send 0.0021 Rinky ethers to pay for this transaction to be added to blockchain. And as soon as this this token is created, you can see here different methods. So since we created this is token of type ERC20, burnable and ownable. You see different methods here. You can burn, you can mint, you can renounce ownership, you can transfer from, transfer ownership. We can see as well the name of the token. Name is Jacek token. Owner is the owner of the address of that token. Total supply should be 0 because we not yet have any tokens. And that symbol is JJTK. And decimals is number of points after comma is 0. And as well here, you can check the balance of different accounts. So if you type here the wallet, my wallet address, and you call it, you can see that the balance is 0. So let's create some tokens. Send tokens to this address, and let's send 100 tokens. Send it to your own address. When we click transact, MetaMask is opening again and is asking us to confirm the transaction, pay for it, of course. And we can see this transaction in Etherscan. Remember, in blockchain, everything is public, in a public blockchain. So whatever you put in the code, it will be always public, and there will be way to find it. That's why there is no privacy in blockchain. If you have some private information, you need to hash it first before you persist it in blockchain. There is as well access control, like public or private, like we know from Java or other languages. It's not private or it's not internal. It will be always visible. And when I minted this token, I should see here the transaction is still pending, and I sent Jacek tokens. Now there is an address of the token. If you copy that address, you can click here import tokens. If you paste here the contract address, this will automatically detect your token. You can add the custom token and import tokens. And now in my address, you can see that apart from Holoni tokens and Rinkinby Ethers, I've got 100 Jacek tokens. Did it work for you guys? Yeah. Yeah, because you don't have anything to pay for the fee. Did you visit that Rinkinby faucet and asked for ethers? So you need to in chat here there is the faucet. Faucet is sending you automatically some ethers on different networks. There is Gorley, Kiln, Mumbai, Rinkinby. We're not right now using Rinkinby. Remember, there is end of life for Rinkinby. So on October 5th, Etherscan won't be available. So please use other networks like Gorley instead of Rinkinby. And please mute yourself because I can hear you. Okay, now as soon as we send that token, guys, maybe you can try to send me some tokens. So, or send me your address, I will send you my token. This is my address, and this is the address of my token. And this is address of my token. Send me address in here in messages. Let's see if you'll be able to see my tokens. Okay, I got one address. I use mint, transact. I pay for this transaction. This is pending. And if you add your this token here, import tokens, and put there that token address, you'll be able to see these tokens. Again, I can send to another account some tokens. And you should see already the tokens. So guys, do you see Jacek tokens? Did you got 100 Jacek tokens? Hello, hello. Did you got this token? I sent to two addresses the tokens. Hello, hello. Yeah. Yeah, but you need to send me your wallet address. Yeah. You can click here. I can click here, send to, for example, this address. I can send you 10 tokens next, and I should have 90 tokens, and you should have additional 10. Another Anush. Okay, I can. I can send to Anush's address. This is not valid address. Wait, I need to copy that part. So I can mint to your account. Minting is means creating the tokens, or I can transfer those tokens from my wallet. So I can go to assets, go to I think I transferred to someone 10 tokens, and send, pick your address and send you additional 10 tokens, send them and confirm. And you should get as well 10 tokens. So from my account should 10 disappear in some time, and they should appear on your account. Again, someone sent me some address. Yeah. Do you see this this token there? Remember, you need to add my token, so MetaMask can see this token. So in assets, you go down, import tokens, and token address, you need to paste my address to my token, this 0xFBB. Then you will be able to see this token. There is something which is called verification of the token. I can as well verify that token, so it will automatically discover it on your wallets. Let me verify this token quickly. And contract got verified. Verification of the tokens of the contract means that soon there will appear the code for the smart contract. So everyone can see the code. This code will be verified, and people could interact with it much easier. Of course, this is compiled code, so you can decompile this code, but it's slightly pain in the ass to work with it. And you can see total supply is right now 400 Jacek tokens, because I created 400 tokens. Okay, let's focus on creating NFTs. So this is token reward voucher contract. I don't have time right now to create an NFT from here. It's basically just adding some adding, how's it called? Adding additional libraries from Open Zeppelin here. But the point is, so you can see what methods are there in NFT and why they are different from each other. So let's focus on, this is a reward voucher contract. Reward voucher contract is NFT I created some time ago for the Holoni project I showed you at the beginning. This is ERC721 token, and enumerable and burnable means that this token has something like a counter, and each token is very unique from each other. In reward voucher, in Solidity, we have something which is called mapper. Mapper is just a regular map key value store. It's mapping a key to the value, and you can put there whatever you want. You can map address to string, or you can map integer to string, or to address, or to some structure. Each reward voucher has different attributes, like a token ID, attestations ID, so those energy attestations I'm attaching to each of those NFTs, energy type, additional type code, which is internal energy net type of production of energy, what's the energy, value, so number of watt hours generated, and purchase contract ID. It really doesn't matter, it's some ID of some other contract with which this contract is connected. So this is just NFT. In constructor, I specify the name of this NFT, so this will be a reward contract and type of reward voucher. And there are a few functions like safe mint, which is basically minting. Minting is a create this contract. From Jacek Token, we remember minting was to what address, what amount. In case of NFT, I've got some data there that I want to preserve. So I want to preserve to which address, what are attestations ID, and this is an array. Type, additional type, number of watt hours in that voucher, and the purchase contract. So when I create this NFT, I need to specify all those things in SafeMint. And this is very important. Only owner, only creator of this smart contract can trigger that SafeMint function. Let me see if this got. Do you remember? Sorry for swapping so fast. Do you remember I was saying that I verify something? That the contract got verified. So which means before there was only this bytecode. Right now we can see the code of the contract. So we can see the code of Jacek Token. You can see other contracts connected to that token, and it allows everyone to either read something from the contract. So, for example, a balance of Anush account. I can see how many tokens Anush has, so I can query that. And Anush has 10 tokens in his address. I can interact. I can see who is the owner and the details. And you should automatically right now be able to see in your assets this token. And I can as well write to this contract. So I can from EtherScan as well trigger functions like again to Anush address, mint, which is create for example 10 tokens, or I can transfer from my account to Anush's account. Yeah, let's go back to Remix. So that's the verification of the smart contract. Yeah, so coming back to this Solidity contract, so we've got different functions here. Let's compile this contract and let's start interacting with it. will be reward voucher contract. So let's deploy reward voucher contract. I can confirm. And similar to ERC20 token, I've got a burn here, I've got mint, but in this time, in mint, I can mint, for example, to the account, to wallet of Anush. I can mint this token, this NFT, some type, some other message value, let's say set 0, and when I transact and accept it, this NFT will be created for Anush account. We can see that in Etherscan. Let's check it. It's still pending. In the meantime, I will just create a basic okay, what's happening with that contract? Okay, now I can see it. We can see here that this was created, and if we go to reward voucher contract, we can see that one NFT was created. Token ID 0. 0 means the first token, and to some other wallet I got from you guys, I can send another NFT, some other type, and some other message. I can transact. I accept that, and this transaction will be pending. Of course, blockchain is very slow, but in a few moments we can see this another transaction. And if I verify that contract, the one I deployed, so this is a reward voucher contract, and this contract, this is the contract's address and reward voucher contract. Please recompile. Okay, recompiling. Okay, it will be verified in a few minutes, so we can see more, because right now we don't see any details. We don't see any details about the tokens. Soon we should be able to see a bit more, and the contract is as well bytecode. Soon it will be normal regular code, and if we can see the holders and transfers, we can see that this address owns one token and this address owns the other token. So how to verify authenticity of the tokens and who owns what? So we know first of all we can see it in Etherscan. But if we just want to verify it from the functions ERC721 standard is providing us, we can use these functions here. So let's see what are the details of the token or NFT I sent to Anush. So I know his NFT was the first one, and this is his address. So this contract already is informing me that the guy who owns an NFT of ID 0 is this address. I can as well do it vice versa. So verify balance of this address, and I can see all the details. So get all the details of that contract, and I can see some type, some other message, value 100. Of course, if you wrap it in some Java client and API, this will be nicely displayed. You can have it for as well the second contract, some other message, which means those are actual contracts and those are actual NFTs. And if we take a look in here, we can see those NFTs those NFT were created for which address, and we can see as well the code input. We can see the details of this NFT. So if this is a license, I can verify ownership because I already know the address who owns that specific NFT. And when you try to log into my app, you need to provide me signature, so I know you own a private key to that address who owns this NFT, and I can see, for example, that your balance of this NFTs is higher than one, or that you own the NFT that you say you own. This is here we allow as well to transfer this token. So there is as well a safe transfer. So from to token ID and some additional data. So you can transfer NFTs as well, like the same like you transfer normal Jacek's token. Okay, do you have any questions so far for ERC721? I know there is a lot of information. It's quite complex, and I'm not explaining you what this internal, virtual, and the Solidity syntax, because it's just too little time. And I want to focus on one more thing, which is actually using the contracts. So do you have some questions to that part, guys? Okay. Yeah. So let's now take a look at how we can use how we can combine NFT with this ERC20 tokens. So you remember I showed you the example of the pool where I chose ID of the reward voucher, and I magically got some tokens as exchange for having that reward voucher. You remember that at the beginning. So let's see the code of the smart contract which did that. This is called a pool contract. The pool contract in the constructor to the pool, we have two parameters: address of ERC20 token, so address of, in this case, Jacek token, and address of reward voucher token. So this contract will swap vouchers for tokens. When I create this contract, I specify here the token. I could put here, of course, Jacek NFT.solidity. As I did with a reward voucher, but since this is an interface, I can and all ERC20 tokens need to implement that interface. This means I can put here any ERC20 token I want. So I can put here Jacek token, Anush token, Ankit token, or Fuet token. So one reward pool can serve for as many tokens as we want. So one reward pool will be able to transfer the tokens. Now we've got reward voucher. Reward voucher is just a smart contract where I can reuse the functions from the smart contract. I have an indicator of the balance. So before you can claim the tokens from the pool needs to have some balance. So the pool needs to have some tokens in it. So I can claim the tokens from the pool. And there is a used vouchers array where I basically block vouchers, so I don't allow to use the same voucher multiple times. In Solidity, we've got something like events. You see in a moment those events. Events can be triggered on demand, and events can be, so you can later hook your application on the events. So you can create observer pattern. You can observe a specific smart contract, and when the event, for example, token deposit is triggered, you can fetch the data from what address and on what amount, and do some programming logic in your application. And the same for reward voucher claims. So when a user claims a reward, so claim the Holoni tokens, we can see by what address, so which address claimed that, number of tokens, and reward voucher ID, which is for which token. So I can as well do some logic in my front-end application to display something, or in my backend application to as well react on events that are happening in blockchain. So that's how we can use it. There is a constructor. So constructor, there is an address, there is a voucher, there is a token. So associate token with ERC20 deployed on that address. So basically, this will allow me to trigger functions from Jacek token, like mint or send or transfer. And this is a reward voucher, which is access reward voucher deployed to that address. So it will as well allow me to get, for example, value or get owner of a specific reward voucher deployed on the address. So in this contract, we've got two methods. One is deposit, the other one is claim. In deposit, we can have amount. So I want to deposit to this reward pool X amount of some tokens, in this case Jacek tokens. What is happening here? There is require. Require will throw an error if this is not correct. So you can think of require as about if this is not fulfilled. So if the amount I want to transfer is if amount is different than 0, it's fine. But if amount is equal to 0, we will throw an error. Pool transfer amount cannot be equal to 0. So if I try to deposit to the pool 0 ethers, it will just throw an error. Another is I'm actually transferring the tokens to that pool. So it means I'm triggering method from the token address transfer from. I specify from what address. MSG sender is the sender of this message, which will be the guy who is triggering this function. MSG sender will be always my address, and address, this is the address of this reward pool. So send tokens from my address to this reward pool address and the amount of tokens. And of course, if this transfer from returns false, this will trigger an error, transfer to the pool failed. As soon as I made this transfer correctly, I emit event token deposited. So I specify from which address what amount, who deposited a token, and I specify here and I increase the balance of that pool. Another is function is claim voucher. Claim voucher allows me to claim this vouchers that I put somewhere that claim the reward for the voucher. So when a user clicks here and picks the voucher and selects the wallet and clicks exchange now, this is triggering the function claim voucher. So I specify here voucher ID. I don't need to specify anything apart from voucher ID because I'm specifying the specific. I'm triggering it on a specific voucher. And there are a few functions before I claim that voucher. First, there is a reward voucher owner of voucher ID. So I check if the owner and reward voucher is the contract. You remember from the constructor, this is a reward voucher contract. I trigger the method owner of, and we can see that method in reward voucher here. And there should be method owner of. And I was checking who is the owner of NFT of ID 0, and this was wallet address of Anush. Or Ilya or someone else. So I check here if the guy who is triggering that claim on that voucher is the owner of that voucher. So I specify here if owner of the voucher of that ID is MSG sender, so the sender of this message, so the guy who signed the contract, signed the transaction. And of course, if not, then I throw an error, Koli is not owner of the NFT. Then voucher not exist, reward voucher already used. So I check if the voucher, if this voucher exists in this array. So I check if this voucher was already used. Voucher not exist is a function where I specify voucher ID. I go over the array of used vouchers, and if the voucher is existing, I'm returning false. If it's not existing, I'm returning true. So I'm checking if that voucher was already used or not. And as soon as I check that the guy who wants to claim the voucher and that the voucher was not claimed in that pool, I trigger the method from the voucher itself and get the amount of money, of tokens I should transfer to this address. So the amount is reward voucher dot get value voucher ID, and that would be my amount. So I can as well check for voucher 0 the amount is 100. For voucher 1 I think it was as well 100. So I know right now I should transfer to the account of Anush 100 Jacek tokens. Then I check if the balance of that pool, so if I've got enough money in that pool, enough tokens in that pool. If not, insufficient balance of pool, someone needs to put in the money. So in case IKEA wants to give some money to the users, and so later users can buy some furniture in IKEA, IKEA need to top up for X amount of tokens, and then the users can claim those tokens and go to IKEA and exchange the tokens for furniture. Then we do actual transfer. So then we call from this ERC token. So in this case it will be Jacek token transfer MSG sender. So remember, I'm transferring to the account of the guy who is owning this voucher. I'm transferring a specific amount, so transfer token specific amount that was the value of that voucher, and I'm making the transfer. And if that transfer was successful, so I didn't throw an error here, I'm emitting the event reward voucher claimed by whom, what amount, and which voucher. So my front-end application can hook on that, or I can do some logic based on that. Plus, it's best practice to emit an event. I'm adding this voucher ID to the used vouchers array. So used vouchers dot push this voucher ID, and I'm reducing the balance, and that should be it. So let's compile it. I'm compiling this smart contract. Will take some time, and let's deploy that. So I pick here reward pool. Now you can see when I deploy it, there are a few parameters in the constructor, otherwise I cannot create. So let's specify Jacek token, ERC20 address. This will be Jacek token. So this pool will send you Jacek tokens. Reward voucher address, this is a voucher address ID, and I do transact. I use my IOTA test one account to sign this transaction. Remember, metamask is a wallet manager which allows you to sign transactions. And this transaction is pending, and in a few moments the reward pool will get created. So now we can see that the balance of reward pool is 0. There is one catch in this smart contract. So a deposit from, token.deposit from. In this case, I'm making a deposit from account of sender to account of this address on their behalf, which means I need to allow this contract to make this transfer. So I need to go to my token. This is just a security, so I need to spender is the address of reward pool, and I want to allow this address to spend 1000 tokens from my account, because I want to send 1000 tokens to that reward pool. You can see here, this is a permission request, approved amount, allow spending 1000 tokens, and confirm. And let's go back to the reward pool and deposit 1000 tokens. So I want to deposit to that reward pool 1000 tokens. I click transact. Will fail. Do you want transfer amount exceeds the balance? So of course I don't have enough tokens on my wallet. So how many tokens I have in my wallet? I've got 70, so I cannot transfer 1000, I can transfer 70. I click OK, I confirm, and in a few moments you could see that those 70 Jacek tokens will disappear from here, and they will appear on the address of the pool. It's right now 0. And my activity is deposit to pool, and this as well. In logs you can see the events. So the value 70, value 9,300 is the value that is still left. So I can still deposit to that contract 9,030, and token deposited from what address. What amount? So amount 70 tokens from this address. So those were events triggered. So those 3 events were triggered. Transfer, approval, and token deposited were event triggered with this one deposit. Now I can check the balance. Balance should be 70, and let's create first voucher. So I want to create voucher for my account. So I create voucher to this account. A value of this voucher will be 20. And some other messages, but it's not important. The important fact is that I'm creating. So I'll have the voucher for my account, and then I can go to reward pool and claim that voucher, and I will get back 20 Jacek token. Okay. The transaction is still pending. And is indexing this transaction, so it will be available in a short while. And you can see here the code input value to what address 07CDD is my address. And if we go to this token, we can see 07CDD token ID2. So this address owns token of ID2, and this address owns token of ID1. And you can, of course, see the details of each of those tokens. Yeah, the token was just created, so before it indexed it properly, it will take a moment. So let's maybe check the token of ID1. It should instantly be indexed. Or if not, then EtherScan is stuck, so you need to believe me on my word. Okay, it doesn't matter. We can see that I own token of ID2. So what will happen if I try to claim in my reward pool, claim token that belong to wallet of Anush, claim token of ID1, transact, execution reverted, Koli is not the owner of the NFT, so works. Let's check how many Jacek tokens do I have. I don't own any Jacek tokens at the moment. Let's claim my token of ID2. It allowed me to make this transaction. I signed the transaction. I can open the transaction in EtherScan. Transaction is still pending. So that's the transaction, and it passed. We can see the details of this transaction, the code input, token ID, ID2, that's the input of this function I triggered, and I can see the logs. The logs is reward voucher claimed by my address, amount of 20, reward voucher ID2, and let's check on the assets. I've got 20 Jacek tokens, so works. If I try to claim the same token twice, transaction reverted, reward voucher already used. So that's how you can use this. And cool thing about this NFTs and this pools and all of that is that you can be sure that that the transactions you're making here are transparent for both parties. There is no double spending problem. There is no problem that someone will create out of thin air some tokens there is no way I can cheat you because this contract was already deployed on the network. So so you can see all the transactions. If I agree with you on something, it will be delivered by blockchain. So for example, if you got a massive reward voucher that will basically clear out the whole reward pool, it means that you generated that amount of energy, and you can claim your reward, and I can do anything about not allowing you to claim your reward, because this is how this contract works. And you can have as well similar contract to verifying licensing, so validity of the licenses. You can have the contract that is verifying the different ownerships, and the idea behind NFT is not to have some scammy, stupid ape created in Microsoft Paint by someone and later claiming this is art, because that's not the point. Of course, you own you own the token that has a hash and URL to this Microsoft painting, painting, but it's not the point. The point is that you can use that to get a very much clarity whenever there is a cooperation between companies, whenever there is complex transfers involved, like transfers of money. I know Norwegian Central Bank is right now trying to use blockchain for in-house transfers and in-house exchanges. So the banks in Norway will not use no longer use SWIFT or SEPA for transfers or for allowing users to exchange different currencies, but they want to use blockchain because, of course, private blockchain, which will be much faster, not the public one. But by having a tamper-proof way of making the transactions, it will get rid of synchronization problem and double spending problem, and gives a lot of clarity. So this is the end. Thank you very much for your attention. Do you have any questions? I know this was quite chaotic presentation. I didn't detailedly prepare it because I was having in mind just Ilya, Fouet, and maybe Ankit. But it's good that you at least saw how you can use Remix, how you can use smart contracts. Of course, all of that can be hooked to Java or Node.js, and you can create API and use that smart contract in a faster way than just clicking in Remix. That was just an example how you can use that. Of course, you can use smart contract for having a vote, so for voting, for lotteries, because if you have a lottery, there is some randomness, and the winner of the lottery gets some reward, and it's very transparent, and you can be sure that no one is cheating here. Or in case of voting, you can, for example, have a power of your vote based on number of tokens you own. So, for example, in organization where multiple people have some voting rights, for example, in FOTPerl, Ankit Vikas has more rights than others, but they can take into account votes of other employees, and based on that you can make some internal voting. You can make some proposals, of course not for such a small company, but in case of bigger companies, it's called DAO. Such things can happen, or in case of some cryptocurrencies based on the stake based on number of tokens you own, you can have that much voting right for something, for some proposals where you want to steer the project, what would be the next epic for you to focus. So blockchain is very interesting. Yesterday there was a merge on Ethereum. Merge was successful, so Ethereum works right now on proof of stake instead of proof of work. Yeah, and it's quite worth getting interested into blockchain, because for the next year or half a year we'll still have BESA, so the prices will still either stable or slightly drop. But with the next hossa, so with next blockchain bubble, next craziness, next NFTs or whatever people come up with, there is, of course, remember, a lot of scam, but this technology, in my opinion, has a lot of things to offer, especially when it comes to transparency, cooperation between multiple entities. It's really worth getting interested, if not into writing smart contract, then maybe into reading a bit more about different projects and maybe investing. So if you don't have any other questions, let me finish that that workshop. And thank you very much for your attention. And if you've got some questions, just hit me on Slack or LinkedIn. Yeah, you can you can find me on LinkedIn. Maybe not adding, but observing me. If you've got some questions, I'm there. So bye bye.